I'll ask you guys first. What is the probability of rolling any one of the 1, 2, 3, 4, 5, or 6?
6 out of 6.
6 out of 6, which is 1, right? So this probability is equal to 1. How about, what's the probability of rolling a 0? 0. Now, so the probability is equal to 0. Now that means that, well, that rule is that the probabilities are always in between 0 and 1. Now you've reported probabilities in other classes as percents, as fractions. Usually in the upper level stats classes and probability in college, they stick to decimals in between 0 and 1. So probabilities are always less than or equal to 1, greater than or equal to 0. Okay? Okay. Now, what is the probability of rolling a 1 or a 2 or a 3 or a 4 or a 5 or a 6?
6 out of 6.
Again, 6 out of 6, but I wanted to do this one for a different rule. That rule is that if you want the probability of all the possibilities, that's going to sum to 1. Okay, so all of the probabilities in a space should always add up to 1. Otherwise, something's missing. So that rule is the probability of all possible outcomes is always equal to 1. Okay?
What is that last bit say? Is it all possible?
Probability of all possible outcomes. Sorry about that. I forgot to write in 1 here. Okay, so what is the probability of not rolling a 5 if you throw a die? What's the probability of not rolling a 5? All right, so what did you say, 5 out of 6.83, we agree? Okay, so this probability is 5 out of 6. Now, this is an important one. Now, you could say, all right, well, that's the same thing as not rolling a 5 is 1, 2, 3, 4, or 6. So you could say 1/6 plus 1/6 plus 1/6. That's the probability of a 1, a 2, a 3. A 4 would be another 6, and then a 6 would be another 6. You could add all those up, and you could do that intuitively. But what's much easier is the probability of something not happening is equal to 1 minus the probability that it does happen. So in other words, the probability that you do throw a 5 is 1 out of 6, right? So the probability of not 5 is equal to 1 minus the probability of throwing a 5. Now, that may seem really easy, like, and you can kind of turn off and say that, whatever. I don't really need to know this because I can always add them up. That's where kids run into a problem when they forget this rule, because in the work you'll be doing with this rule, it's not going to be a handful of dice tosses that you can add up easily. It's going to be a lot of kind of complex calculations and a lot of time that you can save by subtracting from 1 instead of adding up all the possibilities. So really try and take this one seriously, because it's going to save you a ton of time in the long run. Let it appear to the lazy self in you. You're going to save a lot of time and effort if you remember that instead of having to add everything up, I can just subtract from 1. Okay? Now, the probability of rolling a 3 or a 5. What is that? Probability of rolling a 3 or a 5?
4 out of 6.
2 out of 6.
2 out of 6. 2 out of 6, which is 1/3.
I thought it said not rolling those.
Oh, yeah, no. 2 out of 6, which is 1/3. So that's an old rule that you remember. If you have a probability of two disjoint outcomes in other words, P of A or B, you can just add those up. P of A plus P of B. So the probability of throwing a 3 or a 5 is equivalent to the probability of 3 plus the probability of a 5. But that word disjoint, anybody know what that means? Disjoint. I wouldn't doubt it if nobody did. Dave, what do you think? That's what kids get it confused with. Independent events, meaning one does not affect the other. So for instance, if I flip a coin, then I flip it again. The first coin toss has no effect on the second coin toss. So they're independent events. If I have a bag of marbles and I want to calculate the probability of pulling out a blue one and then pulling out another blue one, well, if you don't put that marble back, the probability, whatever you pull out first does affect the probability of what you're going to pull out for the second marble. So those are not independent. But all disjoint means is that you can't have both happen at the same time. This is one die toss. So all it means disjoint means you can't roll a 3 as well as a 5 on one toss. They can't happen at the same time. Okay, so maybe write that little definition down. Disjoint means can't happen at the same time. You can't roll a 3 and a 5 on one die toss. You have to have two die tosses. That's what disjoint means. Can't happen at the same time. Okay, last one. The probability of rolling a 3 on the first roll, then a 5 on the second roll. 3 and then a 5. What did you guys get for that probability? A 3 and then a 5. 1/12.
Yep. 0.02.
1/36.
Yeah, I'm going 136.
1/36. Answer's 1/36.
Yeet.
Now, that rule is the probability of two independent events. Now we're using that word independent. Let's say A and B. Is equal to the probability of A times the probability of B. So it's a then statement or an and statement. So what's the probability of rolling a 3 and then a 5? A 3 and a 5. That means you're going to have to throw twice. So there's 2 trials. So make a little note, 2 or more trials. 2 or more coin tosses, die tosses, whatever have you. Those have to be independent. They can't affect one another. And if they are independent, then you can just multiply the probabilities. But remember, independent means one is not affected by the one before it. Okay? All right, any questions? Are we good? Okay, now. That's times, I'm sorry. Right down here? That's a times. And I just wrote here 2 or more trials. Now. Here comes the fun part. Try and contain yourselves. Usually the first one of these multi-part problems, like I was telling to a couple of kids, you can actually get them wrong because you think, no, they can't be that straightforward. But usually, a lot of times they are. Not always, but a lot of the times they are. This says that there's a success rate of 76%. So that means that the probability of being successful is 0.76 or 76%. So that's all the first question asks you to do. It says, what is the probability that the very first house she's going to have a successful contact? So that's going to be 0.76 or 76%. Okay? Straightforward. The second one says the interviewer successfully contacts both the next two households. So it's A and then B, or A and B. They're in order. It's two trials, and they're both successful, so you want to multiply those. So that's going to be probability of successful on the first and successful on the second. See, I said and. It didn't say or. It didn't say is she going to be successful on the first or the second. It said the first and the second. So you're going to take that 0.76 and multiply it by 0.76. This represents the first house. That represents the second house. And then 0.76 times 0.76. Somebody help me out.
7.76.
0.7 about it.
0.5776.
0.5776. Okay? Now the third one says the interviewer's first successful contact is the third houseful on the list. Now this is where they start to get a little tricky. So it didn't say that the third household was successful. That would just be straight 76%. That says that the first household is the third to be successful. That means that the first two have to be unsuccessful. So you need unsuccessful and unsuccessful and successful. So you've got to multiply because it has all those conditions. So the first is going to be 1 minus 0.76, which is 0.24. That's the first house. The second house is another 0.24. And the third house is going to be, 0.76. So that answer is, somebody helping me out?
0.04333776.
Give me 0.0433. Is that close enough?
No, 0.0437.
There we go.
Yeah.
So only about 4%. And the last one says the interviewer makes at least one successful contact during the next 5 households on the list. Okay? At least one. Okay? So what do we think? If you think about the probability that they're not going to be successful, that's 1 minus 0.776. So the probability that they're not going to be successful is going to be 0.24 for each time over those first 5, correct? So let me see if I can get myself a little room here. So the probability that it's not going to be successful is 0.24. So the probability that it's not successful on every single one of those 5 houses is going to be 0.24 to the 5th, right? 0.24 times 0.24 times 0.24 times 0.24. So could somebody just take your calculator and raise 0.24 to the 5th power for me?
Yeah, I got it.
What is it?
It says 7.9. Should I say the whole name?
What's up? No, just give me the first few digits.
7.96.
No, 0.24 raised to the 5th.
0.24. That's what I did.
0.24 times 0.24 times 0.24 times 0.24, because you're telling me 7, so that's going to be a really big, that shouldn't be, it should be really a lot smaller than that.
The number ends with an E and then -4.
Oh, that's why, yeah. So what is it?
0.00079.
0.00079. Yeah, that's why I gave you scientific notation, Tracy.
Oh.
0.00079. Now, can you subtract that from 1? Why am I subtracting it from 1?
Because from like the 100%.
Yeah, because you're subtracting that from 1 to get the probability that there is going to be at least 1.
Oh, it's negative 0.9992.
Well, I don't think it's negative, but it's just, because you said -1, but it should be 1 minus that, so it's 0.99. So 1 minus that, 0.00079, is going to be 0.99 what?
9992.
So almost 100%. Like Josh said, it's going to be really, really high. Because if you got to figure out, if you have a 76% chance of each one of those 5 houses, if you're calculating the probability that at least one of them is going to be successful, that's going to be really, really high. So what you do is you take away the not part. You say, okay, what's the probability of all of them being unsuccessful? That's going to be 0.00079. And then you just subtract it from 1 to say that that's not going to happen, which means at least 1. Does that make sense? Okay. You guys have any questions for me? Are we all right?